Welcome to our sessions on artificial intelligence. So in the previous sessions, we just dealt with the classification algorithm, that is nothing but our logistic regression. So in our logistic regression, we found out that how to classify our data into different classes. So whether a person survived during the Titanic accident or not, so that is one class we decided upon. So the previous one, what we did was we tried to find out whether the person was diabetic or not. So similarly, we have another algorithm, so which is considered as a better algorithm when we compare it to logistic regression. So this algorithm is called as k nearest neighbor. So what is k nearest neighbors and how does it work? We'll try to understand, and we'll also try to understand how this entire thing is working. I mean, how to implement this k nearest neighbor in a program as well as on a data set, and to classify the particular data into a class. So this is very important to understand. So one thing we already discussed in the previous sessions was, so we divide our supervised learning algorithms into two parts. So first part was our regression problem. So regression we dealt with, that is linear regression and multinomial linear regression, where we had regression for single variable as well as multiple variables. So next we moved on to classification. So in the classification we dealt with how to classify our data. So that is nothing but we are fitting our data into two classes, whether the person has some particular disease or not, whether the person survived or not, it is good or bad, like that we classified into different classes. So k nearest neighbors is also another classification algorithm. So classification means here we are classifying our data into two different parts, that is nothing but class 0 or class 1 in case of binomial classification. So in binomial classification we are dividing into two parts, that is nothing but 0 or 1 or yes or no, true or false, any two comparison parameters. But there are also multinomial classifications where you can classify it into multiple parts, that is nothing but whether your data belongs to one of the three categories or one of the four categories. Today we will be doing something called as multi-class classification, which is not a binomial classification, it is a polynomial classification, meaning that we are going to classify our data into three or more parts. So three or more classes we have. So we'll be classifying our data into three or more parts. So that is what we'll be doing, and we'll also be understanding what is k nearest neighbors and how does k nearest neighbors help us in classifying these data which we have chosen, that is nothing but our data set. So comparing to our logistic regression, so these two algorithms, that is nothing but our k nearest neighbors and logistic regression, works in a totally different way, but the end result is the same. So at the end you are able to classify your data. So that is what you are going to do at your end, but the way it works is totally different. So I have already explained you what is logistic regression, where we draw a sigmoidal graph which is of the form 1 by 1 plus e power minus t. So the maximum and minimum limit is nothing but 0 to 1. So you can't get any values other than 0 and 1. So we have a threshold. So if it is greater than the threshold, your value will be 1.0, else your value will be 0.0. So that is what our logistic regression does. But how is our k nearest neighbors different, or what is this k nearest neighbor all about? We'll try to understand now. So in this example, so we can see the data here. So what is the data that we are having right now is nothing but our x-axis and y-axis. On our x-axis we have glucose levels. So glucose levels of different people. So then on the y-axis we have the label, that is whether the person is diabetic or not. So 0 is indicating the person is not diabetic. 1 is indicating the person is diabetic. So this is the data that we will be using to understand our k nearest neighbors. So with this we can see that it is quite similar to all the data that we have represented, but how is k nearest neighbors different is very important to understand. So what do you mean by k is nothing but, okay, so let me give you a better example of understanding k nearest neighbors. So we'll understand our k nearest neighbors algorithm with the help of this example. So what is this example? Basically we will try to understand. So what k means in k nearest neighbor is, k is nothing but the number of nearest neighbors. So what is k? K is nothing but the number of nearest neighbors. So how we'll try to understand this example is pretty simple. So you're watching a cricket match with all your friends. So suppose you have three friends with whom you're watching a cricket match. So two of your friends will tell that India will win, and one of your friend will tell that Australia will win. So how k nearest neighbor is working is, your nearest neighbors are how many? K is equal to 3 now. So you have 3 nearest neighbors now. So you want to decide which team will win. So what you will do is you will consider your 3 neighbors. That is nothing but you will consider all your 3 neighbors and you will decide that yes. So from the majority we can tell that 2 people are telling that India will win and 1 person is telling that Australia will win. So that we can decide that India will win based upon the factor that majority wins. So this is how k nearest neighbor is working. So if you are considering k is equal to 3, that is the number of neighbors. So you will tell that, so there are 3 nothing but opinions here. So 2 opinions are same, that is India is winning, and 1 opinion is different, that is Australia is winning. So that is how k nearest neighbor actually works. So it depends on the number of nearest neighbors. So if there are 100 people near you, so if you consider k as 100, so your output or your prediction will be depending on all the 100 people. So whatever the majority in the 100 people tell you, so they will decide that. So nothing but their values or what the majority of the people in those 100 people decide, so that will be your output. So that is how your k nearest neighbor is working. So I will come up with another scenario now. Yeah, so now the scenario that I have chosen is k is equal to 1. So I will select that my nearest neighbor is 1. So I will consider only the decisions that are made by my closest neighbor. So what is the problem here that I have is I have only one thing. That is nothing but I have only one neighbor. So whatever my one neighbor is telling me, that I will listen. So if he tells that India is gonna win, I will bet that India is gonna win. If he tells that Australia is gonna win, I will bet that the Australian team will win. So this is the scenario when we consider the situation of k is equal to 1. So what is the problem here? We are underfitting our data. So what is underfitting our data? Even though we have a lot of people from whom we can get our suggestions, so I am restricting my value, that is nothing but my nearest neighbor as only 1 person. So if I have very less values, that is nothing but k is equal to 1, what happens is I am able to underfit my data. So what is underfitting? So I have k is equal to 1, so I am listening to only one person. So whatever he tells, whether it is right or wrong, I am listening to that person. So this is one scenario. This scenario is called as underfitting scenario. So what is underfitting scenario? If you choose your neighbors of a very less number, so if you are choosing your neighbor for a very less number, that is nothing but k is equal to 1, so you are listening to only one particular person. So you are not taking into consideration of all the other people that are around you. That is why it is underfitting problem. So underfitting will reduce your result. So what will happen even though India doesn't win? So you will listen to that person and make the bet stating that India will win because you are listening to only one person. So this is called as an underfitting problem. So next thing we'll have something called as overfitting problem. So in the next scenario that I will be taking is pretty simple. So in the next scenario I will take that k is equal to 4. So what does k is equal to 4 mean? K is equal to 4 means that we are taking into consideration that is nothing but our 4 neighbors. So in these 4 neighbors, what I have is I have added an extra person now. So 2 people are telling India will win and 2 people are telling Australia will win. So what is the problem that we face right now? So there is a tie. So if there is a tie, so how to decide which team is going to win or how to make my decision? So this is the case of overfitting. So we have discussed 2 cases. First is underfitting where I choose k is equal to 1. The problem is I should listen to only one of the nearest neighbors that I have. So whatever is his decision, I should consider it and I should give my decision as such. So similarly, if I choose k is equal to 4, that is nothing but if I consider all the people who are there near me, so then there are chances of my values getting tight. So 2 people will tell India will win and 2 people will tell Australia will win. So the problem is I am not able to make a decision. So here there is a situation of a tie. So this is how, this is the main problem that we have in k nearest neighbors algorithm. So how to deal with this is nothing but choosing a value of k such that you are not making a tie. So if you choose k is equal to 3, what happens is you are choosing the optimum value. So see the basic thing that you need to understand here is since we have 2 classes in the sense yes or no, so or India will win or Australia will win is the 2 classes. So for 2 classes, if we consider k is equal to 3, then there is no possibility of tie. So either India should win or Australia should win. So this is how we need to plan our value of k. So we'll consider a real situation and understand how it is actually working. But with this, you must be able to understand that k nearest neighbor is nothing but a classification algorithm. So what is a classification algorithm? It classifies data into different classes. So it is different from regression because regression predicts only the future values. So this is how you must understand this. So after understanding it as a classification algorithm, so how is this working actually? So working is pretty simple. So whenever you have an unknown data, so you are the unknown data. So if you want to see which class that particular data belongs to, what you do is you consult your nearest neighbor. So how many neighbors that are there nearby you, so you consult them. So you will see what is the value that the nearby neighbors have, and then you take a choice of majority wins and you will consider that majority value as your value. So how is that decided? Based upon the k value. So what is the k value here doing? K is telling you that how many number of neighbors you are choosing. So this is what k is telling you. K is telling you how many nearest neighbors you are choosing. So this is important to understand. So k must not be very large. So if k is very large, you will consider each and every person that is near around you, or each and every data that is around you. So there are chances of tie that may be happening, or there will be a lot of discrepancy in the data. So if you choose k is equal to 1 or a very less value, so then your prediction might not be accurate because you are choosing the next value itself. So this is how you must actually choose the data. So this is how the classification algorithm is working. So we'll see the practical scenario and understand from the graphs how it is applied to the data now. So coming to this particular graph, I have already told you y-axis is nothing but telling that it is nothing but a diabetic or non-diabetic, and x-axis is telling you the glucose levels. So you can see from this data clearly, so until the glucose levels of 90, it is considered as normal person, so it is not diabetic. So the value predictions is 0. So if the values is greater than 100, so then it is predicted as 1. So now I will have my random data put into picture. So what is my random data that I will put into picture is pretty simple. So I will have a random data that is nothing but my star here. So I want to consider my star as the random data. So I want to see whether my star is being diabetic, will be classified as 0 or will be classified as 1. So this is what I will be doing. So suppose what I will do is I will consider the data here. So that is nothing but the data, I'll put it here. So this is the place where I place my data. So how actually algorithm is working is, it will try to find out the nearest neighbor. So as I choose my value of k, so I will choose the value of k is equal to 3. So I have chosen the values as k is equal to 3. So what it will do right now is, it will try to find out 3 nearest neighbors. So which are the 3 nearest neighbors you can see here? So these 3 are the nearest neighbors. So this 3 nearest neighbors it chose. So after choosing the 3 nearest neighbors, what you can understand from here? So you can understand that all the 3 are belonging to the category that is nothing but my green colored circle category or non-diabetic category. So what we will try to do is, based upon majority wins, so I will classify my star as nothing but my green colored circle itself. So this is how your k nearest neighbor is predicting. So similarly, if I have my star, that is star data somewhere around here. So if I have my star data somewhere around here, so obviously if I choose k is equal to 3 again. So if I choose k is equal to 3 again, so this 3 data is getting selected. So then the thing is, based upon the majority wins concept, you can see that this star belongs to this purple colored. So star is replaced by my purple colored circle. So that is very important to understand. So this is how your k nearest neighbor is working. So the fact of advantage comes into picture where we have everything in the middle. So when I have this thing in the middle, so if I have a data in the middle, so that is my data is placed here. So I don't know which data to consider. So now what I can do is, I can try to calculate my distance. So I will try to calculate from my star to this circle, and similarly I will try to calculate the distances now. So if I want to calculate my distance, so I am trying to calculate my distances here. So now the question comes here is, how do I calculate my distance? So there are 2 formulas or 2 distances which I can use. So the first one is nothing but my Manhattan distance and the other one is median distance. So I will tell you more about that. As you can see here, we have 2 types of distances between the points. So what is the 2 types of distances? Euclidean and Manhattan distance. So what is the Euclidean distance? So the Euclidean distance is pretty simple. So when you have 2 points you draw a right angle triangle between the 2 points. So when you draw the right angle triangle between the 2 points, so the hypotenuse distance is nothing but your Euclidean distance. So when you have 2 points, you draw a right angle triangle that is formed between these 2 points, keeping the 2 points as the vertices. So the point at which the perpendicular formed is not taken into consideration. So these 2 points considered, you have created a right angle triangle. So then you are trying to calculate the distance. So how is Euclidean distance calculated? It is nothing but square root of nothing but you can do it in 2 ways. Either you can tell the distance of the hypotenuse, or what you can do is you can use a formula of square root of the points, the subtraction between the individual points. So x2 minus x1 plus y2 minus y1 the whole square. So that is how we are obtaining the Euclidean distance. So similarly, Manhattan distance is nothing but mod of the numbers, that is nothing but mod of your values, that is the only positive values which you are considering, subtracting between the points. So here let us consider this particular scenario. So if you want to calculate Euclidean distance between the point 5, 4 and 1, 1, it is pretty simple. So if you want to calculate Euclidean distance, square root of 5 minus 1 the whole square plus 4 minus 1 the whole square. So this is what is calculating my Euclidean distance. So if I want to calculate my Manhattan distance, how will I do it? It is pretty simple. It is modulus of 5 minus 1 plus modulus of 4 minus 1. So even if it is negative, you will obtain the positive value because distance cannot be negative. So distance is a scalar quantity. It cannot be negative at any point of time. So we need to always obtain the positive value. So that is how we are calculating this. So, or the other way is pretty simple. So if you have this right angle triangle drawn, so the hypotenuse will be always your Euclidean distance. Otherwise, the distance is nothing but the sum of the other 2 sides. So the sum of the base plus sum of the perpendicular will be your Manhattan distance. So one thing you need to be pretty clear here, you can either choose Euclidean or Manhattan, but you can't mix up both. So if you are trying to calculate the distance between points, you need to be clear with one distance. I can either choose Euclidean or Manhattan distance and you can calculate. So what is the difference, or how does it even make a difference between these 2 distances is pretty simple. So it is all for the statistics sake of doing it. So when we take in different distances, the accuracy will vary. So if you are not getting good accuracy with Euclidean distance, you can take in Manhattan distance as well. So this is how you can do it. So there is no compulsion that you need to take this distance at all. So it depends on your value of accuracy and your data set which you are using. So that is how you can do with these 2 distances. Okay, so this is the situation where I tried to solve that. So I have calculated the distances, trying to find out the distance between these 4 points. So after finding out the distance, I found out that actually my data belongs to this format. So this is the format where this is the format. So where 2 classes are telling that it belongs to 0 and 1 class is telling that it belongs to class 1. So I can consider this as my class green colored circle. So it becomes my class green colored circle. So that is how you do your predictions in case of k nearest neighbors. So it need not be 2 classes. So again I'm telling you, if you have another class, that is nothing but if you have a red colored circle class here, so this is one class that is getting formed. Again, you can calculate the distance from this point, and among those 3 things you can try to classify the data. So that is the beauty of this k nearest neighbor. So this is the thing that is getting allowed here. So the next point comes in how to choose the value of k. So how should I choose the value of k? Should I choose 1? Should I choose 3? Should I choose 7, 5 or anything? So always the general convention that is involved is whenever you are trying to classify 2 classes. So if it is 2 classes, that is nothing but when you are trying to classify 2 classes, which is class 0 and class 1, diabetic and non-diabetic. So then if the class numbers is even, so if you have the class number even like 2, 4 and 6, you need to choose k as odd. Why? Because there is no possibility of tie if we choose the k as odd. So that is one reason. So if your class is odd, that is nothing but 0, 1 and 2. So then you need to choose your k values as even. So that is the vice versa thing that you need to follow. If class is even number, k number should be odd. If class is odd number, k value should be even. So that tie doesn't take place. And one more thing, if you are considering the data, that is nothing but your data when you have large number of numbers. So you need to consider one more thing, that is you shouldn't choose 1 as the k value. If you choose 1, it is underfitting. So if you choose all the values, that is nothing but how many values we have here, 4 plus 5, then it will be overfitting. So you should not overfit and you should not underfit also. You should choose the maximum value, that is nothing but the optimum value of k should be chosen. So how to choose the optimum value of k? There is no general convention for it, but there is one. So as you can see in the slide, so as I've already mentioned, the choosing k value is not easy. So if you choose smaller value of k, so noise will have higher influence. So what is noise? So some misclassified data will have higher influence on the result. So large value, it will take a lot of time and it is not worthy to consider all the data. So it is like checking in all the data to predict. So that is not worthy of doing it. But what we do is, as I already told you, odd number of k values if the classes is even, and the vice versa. But one more thing we have, general approach is nothing but k is equal to square root of n. So what is square root of n? N is nothing but the total number of samples. So you can take the square root of the total number of samples to give you the k value. So that is what is one simple convention that we can use. So there is no fixed method of telling that this is the optimum value of k, but the general convention that we use is k is equal to square root of n. So square root of n meaning that n is the total number of samples. So here you can see that our green data, that is non-diabetic data, is 1, 2, 3, 4, 5 and the diabetic data is 1. So our result will be nothing but square root of 9. So which is nothing but 3. So the optimum value is nothing but 3. So the k value you can choose it as 3. That is the simplest way you can choose the k value. So that is how you can actually predict your k value. So that is one simple convention. So this was the simple explanation of k nearest neighbors. So next what we'll be doing is we'll be covering a program which we use k nearest neighbors to classify our data into multiple classes. In the previous example, I just showed you the classification of 2 classes, that is 0 or 1 in most of the cases, but we'll try to put it in another way now. So we'll try to involve another case where we'll be actually dealing with multiple classes.